Hey folks, so in this video I'm going to be showing you a deep dive into the different blueprint nodes that came with the movement component from the RunebergVR plugin. So as you can see here, I am just playing around a little bit with the demo movement level that came with the demo project in the GitHub repo. So if you don't have that, just give it a whirl and try it out and read the blueprint nodes. But what we'll be doing in a while is we're going to actually create a new level and start from scratch, and just so that I can demo or explain a little bit in more detail the different blueprint nodes available for you with this movement component. Alrighty, so let's get started. We'll start with a completely new level just to make things clear. Yep, so let's start with creating a folder from this demo project. So underscore demo. And let's start with a VR basic template. So file new level, VR basic. So this is the basic VR level from Unreal. And let's save that map, call it, just make sure that we're in the right directory. Let's call it demo map. Okay, save. All right, so now we need to set up a VR pawn to use for this level. And to do that, so you can see that I've got the C++ classes for this project, but not the plugin. It's not showing up. So if that happens to you, just click here on View Options, Show Plugin Content, and the plugin C++ classes should come up. Alright, so let's go to the public. Alright, so we need a blueprint class out of this pawn. Obviously, if you're working in a C++ project, you'll use C++, but for here, let's call it demo VR pawn. Okay, and let's save it on that demo folder. Alright, and that's it. We've got a VR pawn. Let's add a few components in here while we're here. Let's add a static mesh component. Let's call it static mesh left. Add a mesh. Let's use the default Vive. File save. And let's just duplicate that. So I press Ctrl W, R, and drag it along to the right controller. Alright, so now we should have a pawn with two motion controllers in it. Okay? And if we go back to demo map, I'll just do on player start, just move the Z to 112. As our pawn is configured for this, so for this default Z axis. Alright, so since we're going to be doing movement, I'm going to add the movement component while I'm here. So movement, so RunebergVR movement. It's an actor component, so you only need one for a pawn. So you just compile and save. And that's pretty much the basic setup. Yeah, we need the game mode, of course, for the for this demo level, so that we can hook up this level to this pawn. So let's just go to World Settings. So you can see we need to override the game mode, so that we can change the default pawn class. Let's just do it this way. Let's click plus here. I'm gonna save it under Maps, Demo, and call it Demo VR game mode. Okay, click that, and let's just change the default pawn class to the demo one that we just created. Yep, there it is. So demo VR underscore pawn, save, and that's it. So now we have a new level, new game mode, and a new VR pawn all ready to go for our movement component. Okay, alright, so with that basic setup, let's just clean up this default nodes that comes up with Unreal, and let's do a free axis movement. This is the easiest movement mechanic that you can do with the plugin. So Let's do it when the motion controller left trigger is pressed. Okay. So when you press the left motion controller, we'll enable VR movement, and when we release it, we disable the VR movement. Okay. So I'll drag this along. I'll enable VR movement. Yep, and we'll also do quickly disable VR movement. Right, so this two basic nodes allow you to do free access movement within your VR level. So pressed and released. Okay, and we'll need a movement direction reference, so don't forget that. So this is the scene component in your pawn, or anywhere else actually, that you might want to kind of tell the node, the enable VR movement, where you should be going. So in this instance, the most convenient, of course, is the motion controller. So that wherever I point the motion controller, that's where I'll be heading. You can, of course, do your own custom direction. And we'll touch a bit on this locking certain rotation axes. Okay. Let's just do a little bit, just make this a little bit cleaner. I'll just do a reroute node there. Do that. Straighten that out. Maybe move this a little bit. Just make it a little bit presentable and a lot more readable. So alright, so there you have it. So we've got, when you press the motion controller left, we enable VR movement. We're moving along at 3. Let's increase that to 5. Just so that we get to see a little bit faster movement. And when you release it, we disable the VR movement. We're using the motion controller left as a movement direction reference. Alright, and that should be pretty much it. We could now do a demo run of this, so VR preview. And we can now just fly around this level, have a quick look around, and just fly back down. So you can see that we have free access movement. So we're just flying around in VR space. Alright, so we've been able to freely fly around the level using a free access movement mechanic. But how about if we just want to kind of skate or glide along this floor here, or basically be walking? How do you go about doing that with a plugin? So there were a lot of requests for this. I made it a lot easier to do it in this version 4. Version 2.11 as of this recording. Alright, so you just lock the pitch here. So using in the enable VR movement, you just stick this boolean field here, lock pitch. And that should be it. And you should be able to just slide or skate or walk or what have you on the floor. Okay, so we're just skating here. We're unable to fly, as you can see. So just hit a wall there and just skate around without being able to fly. So you're kind of stuck on the floor, just gliding along the floor here. Okay, so that's how to walk along your level with just a simple tick of the lock pitch from the enable VR movement node. Alright, so we're moving a little bit slow here on the VR movement. How about let's put a little bit of acceleration. So there's a node that came with the VR movement component that allows you to accelerate. So let's do that. Let's add the motion controller right. So if we press the motion controller right trigger, we're going to do an acceleration. And when we release it, we're gonna set it back, I guess, to the default speed, which is 5 that we've set there on the left motion controller. Okay, so let's drag along the movement component again here, just so we don't have a lot of this crossing of this nodes and lines here. Okay, so let's apply a speed multiplier when we press. So speed multiplier will double it, and the base speed, let's get the base speed from the movement component as well. So let's get current speed. Alright, so what this would do now is, once we press the right motion controller trigger, what will happen is that it will double the current speed. Oops, placed that on the wrong spot. Okay, so it will double the current movement speed that we have with the RunebergVR movement. Okay, and when we release it, let's just reset it back. Okay, so let me get it from here. So let's set current movement speed. 2, 3, or 5, I think. That was the default that I've created. And let's just do a little bit of cleanup here, so that it doesn't look so messy. Alright, so that looks a lot better. Alright, so when we press the motion controller right trigger, we're going to apply a speed multiplier, which is basically doubling whatever our current movement speed is. And when we release the trigger on the right motion controller, we'll set it back to our default current movement speed, which is, for this demo level, it's 5, which we've set here. Of course, you could set variables as well and all that stuff, but this is just a quick demo. And as you are probably realizing now, this RunebergVR movement here, we've got a lot of parameters and variables that are open for you to manipulate during runtime, so that you can create like a lot of different effects from it, or a lot of different mechanics. So yeah, just to make it completely flexible. Okay, just notice I'm still saying teleport beam parameters here. I'm going to change that on the next release. But yeah, so this is for if you want the VR movement component to obey nav mesh bounds. This is the nav mesh tolerance. So alright, so and that's it. We should give this a go. Alright, left trigger, normal movement. Right trigger, speed up. Okay, let's try that again. Right trigger, as you can see, we're doubling our current speed, and we're just whizzing around here, whizzing around this level with a lot more speed. That's awesome. Alright, so that's how you do acceleration for the VR movement component. You can, of course, do a lot better better job on the calculations for the acceleration, just to make it feel real in VR, such as what I did here in this movement demo that I've got in the movement level. So if you look at the 3_movement VR pawn, I'm doing I'm using the trigger axis instead of just a trigger for the motion controller, so that I can get the axis value. That means on what this gives you is a float of how much pressed the trigger is on the motion controller. So I'm using that float to do some basic math on it, so that we get a gradual acceleration and deceleration of the pawn along the VR level. So of course you can do any type of calculations you wish, and because since all of the variables are open, such as the current movement speed is open. So let me just show that quickly. So if we go to VR movement, you could see that the current movement speed, the target rotation, all of those are open for you. So the target rotation you could use to change direction in blueprints if you want to. So you have all of these options open for you, so you can do a lot of fancy or a lot of interesting movement mechanic by using this open variables here. So it's makes it quite powerful. All right, so that's it for movement. And I've also done an additional node here for you, which you can use so that for me it feels a bit more natural. So it's called Bounceback from VR Bound. So when you hit a defined VR bound, you will be bounced back from the direction that you were coming from. So if you say hit this wall here, you will bounce back, and yeah, so bounce back and stop your movement, so that it's you know that there's something in there. Another way is, of course, you can just do a rumble as well and just do it like that. But I thought that the bounce back is a pretty cool way of signifying to the user that there's a bound there and you should not be going there. All right, so if you choose to use that, here's how to use it. Let's add a trigger, a box trigger into the level. So let's just add it on there. Let's scale it to let's scale it to 20 maybe, and on the Z maybe 10. Yep, so just something rough. All right, so around this region here, if we hit it, we want the user to be bounced back. Okay, so how do we go about doing that? So we go to the level blueprint, and it's just to clean up the default nodes, and let's add an event for the trigger box that we just made. Let's do add on actor begin overlap. Other actor, we should check if it's our demo VR pawn. So cast to demo VR pawn. And if it's a demo VR pawn, so get RunebergVR movement component. And let's get that bounce back from VR bounds. So in this scenario, I'm using the level blueprint. Of course, you could use the actor blueprint as well if you have actors that you want to, and then do an actor begin overlap on your meshes or skeletal meshes or what have you. All right, so bounce back from VR bounds, movement speed. You can do some fancy stuff like get the current movement speed, and then so that when you hit that that wall there is, you're gonna get bounce back depending on how fast you actually hit it. So, but here let's just make it 10, just so that I want to show you how in a very visible way how we're bouncing back and how long the movement would last. Okay, and you can also reset the movement state after bounce. That means if you hit it, because by default what it will do is it will bounce you back from the direction that you came and stop the VR movement. If you click this, it will still continue, so the movement after you've been bounced back. So you could do that as well. All right, so let's just try this out. Let's try to hit this wall. Boom, bounce. Another one. Boom, bounce. And there are a couple more nodes available for you, kind of like bonuses out there for the different type of movement that you might want, and should complete your arsenal of movement mechanics that you can freely manipulate the variables of and just create a lot of interesting or different movement mechanics. All right, so one of them is, I'm just going to show you one, and then you can play around with the rest. Is, well, there's just really two more. I'll do the dash movement. So I'll do a timed dash move. So what this does is if you press, or based on an event, of course. So let's just do that. Motion controller left face button. Let's use the face button 1. So face button 1 maps to the up button on the trackpad on the HTC Vive, for example. So you press it. And what it does is, for a period, by default, it will move it will move you for 5 seconds with a movement speed of 3. You can, the movement direction, let's use the motion controller left, get world rotation. Okay, and you can use that as a movement direction. Stretch it out and so make it look a little bit cleaner. Alright, so yeah, so that would, if you press this up button in your motion controller, it will give you a time dash move, which is sort of a movement of 5 seconds automatic and on a specific direction, so you could set your own custom direction. Yeah, so the other reason why I created this is some people also wanted kind of like a straddle left and straddle right, so you could do your calculations on based on the world rotation and get the left and right, so that you can have your own custom movement direction. So when you press a button, for example, it'll move it on a straddle left and a straddle right if you like that kind of mechanic, okay, or need that kind of mechanic for your game or VR experience. Let's just try this. Alright, so as you can see, you could just, it just basically gives you an automated movement for a period of time. And yeah, so just add 90 degrees in certain rotation directions so that you can do the straddle left, straddle right, or even move backwards if you want to, or make it jump if you want as well. Make the pawn jump. If you want a bit finer control than what this node gives you, I've also created a timed movement component. So it's basically the enable VR movement with a time component, so a duration component here. And you can also do, because this one you kind of lose the locking ability. That means the user, if I'm doing it just like this, I did something simple here, just get the world rotation, so it'll basically allow the user to move up and down the level, where before we kind of stopped them from doing that by doing a lock pitch here, but which is valid if you want the user to jump, for example. But if you want a bit finer control, so you can use a timed movement node, which is pretty much the same, kind of like a combination of the time dash move and the enable VR movement. So it's an enable VR movement with a duration component on it, duration parameter on it. All right, and you could do a custom direction, or you could use a movement direction reference. All right, so that's pretty much it for the RunebergVR movement component. If you've thought of any other convenient movement mechanic that you, a movement mechanic that would be convenient if I open up a node for you, just let me know, and yeah, and I'll try to add and include it into the code base. All right, so I hope you enjoyed that, and yeah, have fun. Cheers, and see you in the next video. Bye.